All right. So what are we talking about? Once every hour, and this is the data that we want to insert in that table. And this will be the classic insert statement, right? Insert into meter data, and you give all the column names, and this is basically the value. So what we're going to do is the current velocity is once per hour. So what we'll try and evaluate is what does this velocity mean to the size of the partition. So let us take, for instance, an hour later, the meter transmits the data again. You can clearly see that this portion of the column or the two columns will remain identical. The data remains identical. This becomes 10 o'clock and this becomes 15. And let us say seconds was 22 and this time was say 195. And then we've got some more data. So these are the two data sets. There's a first hour and this is the second hour, right? And now what basically happens is, right, you are going to store this data in Cassandra, right? So how does that work? If you notice that if I hash these two, that's my partition key, the hash value is going to be identical, isn't it? It's going to be absolutely identical. So what basically happens is you can clearly see that based on these two columns, I can uniquely identify both the records, right? That is a given. Further, what I want us to really look at is if every hour the meter transmits the data, then what will happen is after 24 hours, the partition key will change because that's when it will becomes 2102 and this will become 20. So the partition key will change once every 24 hours. So given this, that the partition key stays constant for 24 hours, how many records will a partition hold? 24. So you can see that if I continue doing like this, there are overall 24 records that will be stored against this partition key before a new partition is created. So you can clearly see this velocity determines the size of the partition. Make sense? Now, why don't we change this? And let's take a look at what if this were to transmit once every 15 minutes. Once every 15 minutes. So in that case, what will end up happening is the total number of data records in a given day is going to be, we've got 24 hours times 4 is equal to 96 records that gets generated on a daily basis. So for the same partition key, now my partition size is 96 records. So if I were to draw this, right, so that you can get an idea in terms of visually what it might look like. So think of it like this is M001. I've got 20210119. That's my partition key. And this is the record number 1 at 9:15. This is going to be my record number 2 at 10:15. And like this continues. Obviously, the assumption is it has started at midnight, 15 minutes past midnight. That's when it has started. And this is how the records are going to build up. This is called as the size of, the partition. Okay. And if I look at an increased velocity, it will have the same partition key, but the size of the partition now is, here it is 24 records, here it is 96 records. You can see that this is the partition key and that's all the rows. And that is essentially what Cassandra is all about. It's a row-oriented store. And I did mention this, whereby I said that the row will grow horizontally. This is where the data will keep growing horizontally. So a natural conclusion of that is, if this row becomes very, very big, then naturally Cassandra is going to begin to struggle. But before that, let's do some more experimenting. What if the velocity increased to once per minute? So my partition size is going to be 24 times 60, right? Is equal to 1440. So my partition size, just by increasing the velocity, has become significantly larger. These many records. Why don't I increase that even further? How about increasing this to once every second? So it's going to be 24 times 60 times 60 is equal to 1440 records. You must be wondering what happened to my math. How can 24 into 60 is 1440? And how can 24 times 60 times 60 is also 1440? You must be wondering what's going on here. In order to understand this, by the way, this was obviously not a math quiz. So in order for us to understand this, I want to draw your attention back again to the primary key. If you look at the primary key, the partition key is meter ID and date. We got that. I want to draw your attention to the clustering columns, hours and minutes. So when I increase the velocity to once every second, will it be possible for Cassandra to uniquely identify a row with the existing primary key where the last column is the minute? Not possible. So this is where you will get upsert. Existing set of records will be updated. So that means you can increase the velocity, but the number of records per partition will actually be this. So you're going to get 59 upserts. The final record for that minute is the only one that it's going to retain. So what will appear as though you are inserting data in Cassandra, but Cassandra seems to be losing the data. In order for you to ensure that yes, indeed, there are no upserts happening, you can ask Cassandra to read before writes, which means you can do what a traditional RDBMS does. And it will tell you back, hey, wait a minute, right? A record by the primary key exists, and therefore I'm not going to allow you to save this data. But there is a cost associated with it. If you do not read the data before writing, your velocity of writing into the database or data store is going to be much higher. Because remember, for every writes, if you are going to do a read before, that means for 1,000,000 writes a second, you're actually doing 2 million worth of work. 1,000,000 reads and 1,000,000 writes. And we don't want to do that, because there is only one thing that Cassandra is designed for, and that's performance. Well, I can add two more, performance and performance. That's the only thing you're going to use Cassandra for. So therefore, how do we address this issue? I do want to store data right at this velocity once a second. I have to modify the primary key.